Hello everyone. I'd like to welcome you to today's webinar series event sponsored by KPI Partners. Today's topic, a mix of art and science, how to achieve high performance business intelligence, will be led by Jeff McQuigg from KPI Partners. Jeff is a senior architect for KPI Partners who has 20 years of experience in the business intelligence space. Jeff wrote the certification exam for Siebel Analytics, which is now Oracle Business Intelligence Enterprise Edition, and has personally been involved in over 35 Oracle BI projects in every capacity. As a respected thought leader within the business intelligence community, Jeff frequently speaks at industry events such as Oracle Open World, and we are honored to have him here today. If you want to find out more about KPI Partners or how we can assist your organization with Oracle Business Intelligence, please contact us through our website at kpipartners.com. I will now hand the presentation over to Jeff McQuigg, who is located somewhere along the West Coast. Jeff?
Thanks, Jeremiah. Welcome everyone to today's session. Today we're going to talk about high performance business intelligence, and particularly how do we plan to achieve this. We're going to hit kind of the top to bottom of this. We're going to hit all layers of the technology stack. So we're going to hit both the user interface, the OBI server, but we're also going to focus quite a bit on some of the things you need to do in the database and database design. Before we really dig into it and how to tune things, I just want to make sure everyone's on the same page as far as what an OBI query and what a report and dashboard actually goes through to make it happen. At the very top, we start with our dashboards, which contain a series of reports and prompts. These are translated by the presentation server into what's called a logical SQL statement. A logical SQL statement is then passed over to the OBI main server, the OBI EE server. And a couple things happens here. One thing it's going to do, it's going to say, have I already executed this query or something very similar to it in my cache? If so, it's going to go ahead and do a quick lookup and send it right on back to the user interface. But more commonly, what's going to happen is OBI server is going to translate that logical SQL statement, that logical request, into a physical SQL statement that is tailored towards the target database that you'll be using. So it sends that piece of text to the database. The database is going to do the majority of the work here in processing that SQL statement. And then it's going to return the data set back up through the stack. The OBI server may do some additional work on it if the database can't do everything, or if there's multiple queries issued. And then it's going to go ahead and return it to answers, and answers will format it for a dashboard. So that's kind of the round trip. Sorry for that technical glitch, everyone. Okay, so when we take a look at that entire stack, we have to keep in mind that OBI, also called OBIE, is a relational OLAP engine, which means that it is a SQL generation engine. And that is fundamental to the way this product works. We really must think about that all the time. And what that really means is when we're looking at performance, it's a combination of our database design, how our data is structured and the database features that we use in our database, but also how do we access that data? In other words, is the SQL that we generate, is it going to get efficient access to that data set? When we look at the stack here, again, we get our most bang for our buck down the lower we go into our database layer. That's where the majority of the work actually happens. We can do some good things in the BI server layer. Caching can certainly help there, and our main goal there is to make sure that we generate proper SQL. And then finally, at the very top, there's probably less impact that we can achieve on the user interface. However, we are going to cover some things that you want to make sure that you don't do, or that you do to make sure you're getting optimal SQL statements from your user interface. Okay. So this webinar is really about planning to do the design from the beginning. So when you start your project, these are the things that you need to make sure you have covered as you're going through your requirements and, most importantly, your design. This is not really a performance tuning session. That's kind of after the fact. This is before we actually go ahead and achieve things. All right? We're really going to focus on where we get our most bang for the buck. And I want to make sure that we don't talk too much about certain BI server settings such as clustering and various SQL generation options. We want to make sure we get the core of our architecture working smoothly. Okay. So Jeremiah told me a little bit about me. I have been doing OBI and SQL Analytics for about 9 years, and I've been pretty much working exclusively during that period on SQL Analytics and OBI. Let's start at the bottom of the stack. Let's talk with our physical data model. Our physical data model is where everything really starts. We really think about the model, the way the model looks, the picture when we draw it out is our main weapon in achieving good performance. There are all different kinds of models out there, and what we're going to talk about and what we want to try and go for is what's called a star schema. It's also called a dimensional model. These dimensional models are really kind of a different way of using regular, normal relational modeling, but with slightly different rules. It uses standard tables and foreign keys and indexes, but it's a different way of using them. So this is where we get our most bang for the buck, I believe, is in making sure we have a good, proper star schema. For those of you unfamiliar with it, this is a very simple looking star schema. A transactional system which captures this information is going to be modeled differently. But here we basically have two kinds of tables. In the middle we have something called a fact table, which holds our basic measurements, metrics and facts. Those terms are synonymous. So here's where we put our dollars, our amounts, our quantities, our counts, prices, etc. Everything that we are going to measure is called a measurement or a fact, and we're going to put it inside of a fact table and only in a fact table. Well, a number by itself is not very useful, so what we do is we're able to slice and dice it by various dimension tables, and these are typically geography, customers, everything, products and things like that. These are the things that are more textual in nature. It may be a customer name or a geography or a month or a quarter. For more information on this, I'd recommend you read the seminal piece on the topic by Ralph Kimball. It's called the Data Warehouse Toolkit. Ralph Kimball is the person who popularized dimensional modeling years ago. Okay, but we're not going to get too much into that. That's a whole topic into itself. What I'm going to talk about here is how dimensional modeling works for our mainstream databases, such as Oracle and DB2. Some of the things in here may not necessarily apply if you have a Teradata or a data warehouse appliance system. The very first thing that we need to think about when we're talking about dimensional modeling is that it is designed to denormalize our dimensional data. And the reason that this exists is because joins are expensive to a database. It's more work that the database has to do. So what do? We kind of pre-join it and we denormalize it. So if you see the picture on the right, we have a typical calendar dimension. Well, what we actually do via an ETL process, which is where we transform our data on a batch, usually a nightly kind of process, we flatten it out into one wide table. And we put all of our information at different levels into one wide table. The benefit of this is it cuts down our joins, and that is an overarching philosophy that you should always think about when designing your data models. If there's an extra join that you can get rid of it, think about denormalizing it to remove that join. You're going to get better performance out of it. Okay. It doesn't just deal with putting fields together from different levels of a hierarchy. It can also denormalization can also help you link things together more quickly, again, with the goal of cutting out joins. So we see two different options over here. On the left, we have, if we want to do order line information by an order date, well, if we have a model such as on the left, what's called a Snowflake model, we actually have to do two joins. That's additional work the database engine has to process. However, on the right, we have a more typical star model where we have a straight and direct link. So the philosophy, again, fewer join hops is better performance. And how do we do this? We can use the ETL to do this, to actually physically link those two. One note, a view in the database is not actually going to link anything. It's just going to make you think it links together. Behind the scenes, it still has to join the three tables together. Right? Here's another kind of, this is more of a rule of thumb. The Oracle BI middle layer, which is called the business model, is a logical representation of what we want our BI system to do. It defines how things relate. Well, a general rule of thumb is the more you can make your physical model look like your business model, the less translation OBI has to do at query time. So if we can make, it's not always possible, but if we can make our physical model, generally speaking, look like our business model, then we've simplified our physical model, and that's what we're after here. So in the previous example where we had an additional hop to get from order lines to order date, well, we said that's not an optimal model. The picture on the right is a cleaner, simpler model. Okay. Another technique that helps us out substantially is to pre-calculate things and store them in the data model. In many cases, you're going to have very complex calculations. Commonly, we find this in our metric calculations. Sometimes metrics may take pages upon pages of SQL to actually compute the metric. So the philosophy here is do it once versus do it often. We want to do it once at night. We can put all the complex logic in our ETL loads to pre-compute and store it as simply as one field in the database. Again, our goal is to have a simple query. And this is really one of the main differences between a data warehouse and a data mart. And I urge you, as you're thinking about building your BI application with your data mart, you want to tailor that data model to a specific use. A data warehouse, however, is more generic in nature, and you probably don't want to do these things. So don't be afraid in your data mart and your data model that OBI is reporting on to tailor it, to make customized fields, to make specialized tables, to do what you need to do to make sure it performs well and has a nice clean highway to your data access. Aggregate tables. Most people know some things about aggregate tables, but let's talk a little bit more about what they are and when they're useful. So generally speaking, an aggregate table is something that is useful for summary kinds of reports. While our base fact table will store information at the lowest level of granularity, frequently we want to see things rolled up. So we may want to see things by month or by state as opposed to an individual transaction or an individual customer. So what we can do, again, in the ETL is we can pre-compute some of these aggregations. And our goal here is to make a smaller table. So in the picture on the right, what we've done is we've aggregated up along several dimensions. We've moved from day to month, we've moved from product to product line, and from store to state. And we have our same metric in there, but what we've actually done is we've cut the number of records down substantially. So this simply means that when Oracle, OBI, and the database use this smaller table, it's going to be much faster, right? So generally speaking, we like to shoot for at least a 10-to-1 row compression ratio. We don't want to be making too many aggregates because then we'll have what's called another problem called aggregate explosion. We build this aggregate table, we map it into OBI. Now OBI can pick which table to use based off of the query that's coming in. OBI is called aggregate aware, and it's going to navigate to the proper aggregate based off of the actual query coming in. Right? Caution, and this is something that I think folks sometimes don't think about too much. I think a lot of times people think aggregates are free, but they are not, of course. There's additional code that has to be done. It takes longer to execute this code in an ETL batch. It takes more storage, it takes more OBI mapping, and it takes more QA work. So some of the things we're going to talk about coming up are things that you should consider, quite frankly, before you do an aggregate table. Right? Technique number 4 is creativity. Dimensional modeling has a couple of foundationary rules in them. If you read the Ralph Kimball book, I think about the first third of the book lays out what those rules are. However, the remainder of the book and the remainder of what we actually do to make a good dimensional model for our specific application is really art. There are a lot of interesting things that you can do as long as you keep a couple of the basic rules in mind about denormalization, about cutting down joins, about keeping your grains consistent. As long as you keep these basic rules in mind, you can come up with some pretty interesting solutions. And remember, we want to tailor our solutions to our particular BI solution. Again, the data mart versus data warehouse discussion. Right? So keep those things in mind and be sure you weigh the cost of every design decision because there's always a cost. Next, I want to talk a little bit about the database itself, some features that we can use in our database. And I'm going to focus really on the Oracle database here. And in particular, I'm going to focus on 2 key features. These are things that we, generally speaking, always want to have in our dimensional models. So we're going to talk about partitioning, and we're going to talk about star transformations. So these are features that have been built into the Oracle database over the years. And in many cases, they have multiple purposes. Partitioning, for example, can help a DBA manage a very large table. But both of them are really useful for data warehousing applications because they are designed to process very large data sets more efficiently. In particular, Star Transformations is really only designed for BI tools and database access. Let's talk about partitioning. Partitioning will essentially take a very large table and break it up into smaller pieces. Quite physically, it actually does it as a collection of much smaller tables that are kind of logically merged together. So when we don't use partitioning, our data happens to be spread randomly all throughout a very large table. So if we're interested in the orange data on the right, the Oracle database doesn't know exactly where it all exists, so even with an index, it's going to have to scan the entire table. All right? Now, when we talk about partitioning, what we're doing is we are telling Oracle, this is how I want you to lay out the data in a specific way. So what is very common is we do a monthly partition, which means that all data for a given month will go into one of the boxes. So if we have a query that's only going to hit one particular month, it will only hit one of the partitions as opposed to the entire table. So a query on the right, for example, if we're looking at 2 months, we're only going to be looking at 25% of the entire table. Well, the benefit there is that is a drastic reduction in your IOs, and it's going to improve your IO query time. Partitioning is something, quite frankly, I think you should pretty much always do on every fact table. Fact tables under a few thousand records or a few 100,000 records, perhaps you don't have to, but when you're in the millions, definitely consider partitioning, commonly along a time dimension. Star Transformations. All right. This is a feature that's been inside the Oracle database for a long time, and it is custom designed for what we do here with Oracle Business Intelligence. Since we deal with star models in our OBI solution and in our physical database, a star transformation is a way that Oracle can specifically optimize for that kind of query. What it does is it recognizes that this query is going to operate on a star model, and it's actually behind the scenes, it's going to change the way it attacks, its execution plan, the way it attacks the data. Now, normally, when you join to a table, only one index can be used on that table at a time. So without a star transformation, we may attack our very large order facts table by one dimension. Maybe it's by time, maybe it's by customer. But with a star transformation, what it's going to do is say, I want to know all the records where a particular time, a particular customer, a particular employee. So it uses them together. So the more dimensionality we have, the more granularity, the more detailed our queries are, the smaller percentage of fact records we're going after, the more useful star transformations are going to be. For example, you can have a multi-billion row table, but you can do a lookup, again, assuming you're going after a small subset, in perhaps a second or two. It can be very fast. All right. So let's take a checkpoint here. Do these things really work? Well, recently I had the benefit of actually doing a performance tuning effort on a financial analytics system. This is using the out-of-the-box for the BI apps, the data model, which is a Snowflake model, and it's not a star. Partitioning and out-of-the-box is not used. That's up to the consultants to implement that. And although star transformations were happening, they weren't really happening to their fullest potential. They were partially used. And part of that was because the Snowflake model makes it more difficult for the database to do that optimization. So employing only star transformations and partitioning, we improved our average report time substantially, and our number of reports that met the user's actual expectations for them went up dramatically as well. Now, we weren't finished. I'm going to talk about some other things we had to do to make these numbers even better. But the point is, just doing these two things alone can have a substantial impact on your overall performance. Now I want to talk a little bit about the OBI server. So we talked about the data model, right? Let's say we have a great data model. It's designed with performance in mind. It's got all the database features working. Well, it's kind of useless if we ask it the wrong questions or we ask the question in the wrong way. And the way we ask the question is with SQL. OBI is pretty good at actually generating the SQL based off of the configuration you've told OBI. And if it comes out that the SQL is not correct, it's not typically OBI's fault. OBI 9000 on the right will say, hey, it's not my fault, it's human error. There's something that you didn't do right inside your repository. There's an incorrect piece of configuration or perhaps a missing piece of configuration. So we have to go back and make sure that the SQL that we're generating is perfect. And it's going to be very important that you get to know the NQ query log file and get to know your SQL, right? So when we build a report, or when we're building out our repository and we're doing some unit testing, when we run a test query, we should know precisely what the SQL should be before we even look at it. And this is a key thing to being an OBI architect. We must know the answer before we go and take a look at it. Are we using the correct number of queries? Are the right tables involved? Do we have too many tables? Right? Do we have the right joins? These are some things we need to know. Right? So I think it's very important as a development team, as a BI architect, to brush up on your SQL knowledge. Understand how all these things work. Understand the kinds of advanced SQL that OBI actually generates. Understand why there are certain portions of the SQL there, whether it's a union or an outer join or a partition by, an aggregate window function, these kinds of things. And it's getting harder for us because now OBI is generating even more complex SQL statements, right? So again, back to the what we need to know about our queries and what we're expecting. One of the things that I see quite commonly is if we know the right number of queries that should be generated, and it turns out we're expecting 2, but we actually see 3 in there, well, it's not OBI's fault. We've probably done something incorrectly, right? Keep in mind that when we say number of queries, we're really kind of talking about number of select statements. OBI can actually generate one very large query with actual 2 select statements in it, and it'll merge the 2 together inside the database. That's one way to do it. Another way to do it is to have OBI generate 2 separate queries. The database returns the results, and then the BI server will actually do the merging together. Now, there's no best way to configure this. I think you're going to need to go ahead and benchmark it. It's a very simple setting. Try it out. I've seen cases where the single large statement with the full outer join is faster, and I've also seen cases where sending multiple individual queries and then letting the BI server do the merge, I've seen where that's faster as well. So no hard and fast rule there. It depends on quite a few things. Right? Here's a small thing. This is relatively simple, right? But let's take a look at our physical layer. I've seen this create problems every now and then. We need to make sure the nullability is actually accurate in our OBI server. Right? If we set our nullable field to be true, well, OBI is going to generate additional wrapper queries or syntax around that to make sure it can handle a null value. And so you might get this syntax in the middle of the screen there with this NVL syntax. Well, that's not going to be as efficient as a simple straight join. So if your region name field actually is a not null field, then ideally you set that in the database when you build your DDL, and then when you import, OBI will import that nullable flag. But if it's not the case, make sure you do a review and make sure your nullable flags are set correctly. Here's a common one that we see. If you run the query and you see that there's an extra table in the query, well, how did this table get in there? Obviously, it's bad for performance because it's going to do an extra join, or it may even do a Cartesian product. So we don't want that in there. So how do we make sure that we don't have these extra tables in there? A very common reason for this is using complex joins in the physical layer. So in this example here, we have company complex join to company details. In reality, it's a one-to-one join. You see this quite a bit with something called an extension table. But Oracle gets a little bit confused sometimes, and it will frequently add the company details table into the query, even if it's not needed. So if you see that scenario, say, why is company details in there? Well, the solution is we can change the way the join actually operates in the physical layer. We can model it, instead of a one-to-one with a complex join, we can model it as a parent-child. Now, OBI is pretty good at making sure that parent tables are never included in queries unless they're needed. So simply changing this join to look like the picture in the left will eliminate that company details table from being included in the query. A very important one, and this is why we have to look at our SQL, and this is one of the very first things that I look at when I see a bunch of SQL statements and I'm trying to figure out what is happening with this query. Why is it issuing these 6 queries? What's going on here? one of the very first things that I focus in on is the group bys, the granularity of the query. And I want to make sure that the group bys are correct based off of what I know the report to be. Now, if we don't have a group by, so a group by is going to summarize our records. If a group by is missing or it's at a lower level of detail than we like, well, this can be potentially very bad for performance because it's going to return a larger data set. If you don't go ahead and do a group by, this can be as bad as returning gigabytes over your network to as simple as a couple 100K or even a kilobyte. Now, there could be a variety of reasons why this doesn't occur. Sometimes there's simply no option. For example, account distinct does not exist in Microsoft Access, so OBI has to bring everything back. Sometimes there's a function that's not enabled in the Database Features tab. Frequently, though, it's also a problem of configuration on a logical table source in what's called the Content tab, which is the most important part of OBI configuration. So one of the things I would recommend you take a look at, if your group bys aren't what you expect them to be, confirm your Content tab and then take a look at your Features tab. The Features tab is on the physical layer and it's set up on a single database at a time, and it controls the capabilities that OBI thinks the database has. And so go ahead and make sure that your features are accurate. Commonly, you don't need to do this very much, but once in a while you may have to. Sometimes it may be incorrect. But go ahead and just make sure that these are correct and they're generating the right SQL that you want it to see. Here's a question I see quite a bit, fact-to-fact joins. Well, what if I want to see assets and agreements together along with contacts? Well, if you model it like that, we're joining two fact tables together, and there's some problems with that. Number one, the database is going to have to join potentially two very large tables together, which is going to be horribly slow usually. Number two, it doesn't really handle cases where there's missing record sets. In other words, you really need to do a full outer join. That's going to make things even slower. Well, the way we actually want to model this inside of OBI is with a conform dimension. And so towards the bottom there, what we prefer to have is instead of one large query, we actually want to model two smaller queries. So we do a join with contact and asset. It returns a result set. We do another query with contact and agreement, and it returns a result set. And either in the database or the OBI server, those two small record sets are then joined on contact. So this is what's called a conform dimension query, a conformed query, and this is something that we want to do instead of fact-to-fact joins. Connection pools, not too much to really think about here. Primarily when we want to make sure we're using our native call interface, and for Oracle we don't want to use ODBC. Our maximum connections by default typically starts at 10, but we actually want to increase that to a value that will actually handle a percentage of concurrent users on a logical page. So if a particular dashboard page fires off 100 queries, we need to keep that in mind, and we need to do the math on our expected concurrent user set. Okay. It's important to note that there's really not much we can do here in our physical layer. It really comes back to our logical data model design. I do want to talk briefly about caching. Right? So OBI does have a very good caching engine. It caches the results of portions of various SQL statements, but there's some problems with it. Really, when we think about caching, caching is not a panacea for performance. There's many cases where caching does not help us. If you did a real-time ad hoc system, caching doesn't do anything for you. When you have very tight security, the effectiveness of cache is reduced. When you have highly interactive dashboards, also it becomes very reduced. So the key takeaway here is do not rely on caching. Rely on the other things in this discussion first. Think of the caching as a cherry on top of a great sundae. Okay. Now, generally speaking, if we follow good practices, right, we follow good dimensional model designs, we configure our RPD correctly, we do our database features tuning, from the very get-go, you are going to have a pretty well-performing model. It's going to work for you in a variety of situations. Are there enhancements and specialized things you can do later on? Yes, of course there are. But if you follow those basic things right there, your foundation, your infrastructure is going to be in a pretty good shape. Let's talk about some of the things we can do on the reporting side. Now, as I said before, the reporting side does not have typically speaking, does not have a tremendous impact on performance. However, I have seen cases where there are significant problems based off of how the report was built. And in fact, just recently I saw that. The very first one was make sure the report developers, whether it's an ad hoc user or the development team, have the right fields to use. Because if they don't, they're going to have to do potentially horrible report workarounds, maybe with unions, maybe with substantial case statements. So provide things like a robust date dimension so they can do slice and dice and do math on their date much more simply. Provide metrics such as year to date and quarter go and other kinds of things. Pre-build these things for them. So now it's much easier for them and they don't have to do a lot of report logic. Right? Number two, on a dashboard page, sometimes you could actually, if you were to display a chart and a table side by side, you can either put the same report on a page twice, or you can make a compound view in one report and just display the compound view. Now, in cases where you have a special formatting thing that you cannot use a compound view, keep in mind that if you put the same report on a page twice, it's going to execute that report twice. So it's going to double the overhead. It's going to double the workload just for that one report. So try and avoid doing that. Number three is kind of self-evident, I think. Don't overload your pages, right? You need to think about how much work is being performed on a particular page. Although the page may look simple, this particular page here behind the scenes is actually generating 32 logical queries. That's a lot of work on the database, particularly when one logical query may behind the scenes actually generate 2 physical queries. So this right here could potentially be 64 physical queries hitting the database all at the exact same time. That's an enormous load. So think about ways of consolidating and simplifying your dashboard pages. One note, if you have things such as hidden sections to do just that, well, unfortunately, if it's in a hidden section, OBI will still fire the query behind the scenes. So unfortunately, that doesn't buy you very much. Number 4 is a very important one, and I see this quite a bit. This is something that I like to do as kind of a review of the reports that have been built as we go into a QA. Make sure the granularity of your output and the granularity of your criteria tab are in sync. Because if they're not, OBI and the Oracle database can be doing a lot more work. So if this is our output, this weekly office trend, the granularity of this query is week and office. Okay? It's going to trend different offices across various weeks. So it's real simple. But if we go back to our criteria tab, and that's what we see office, employee, day, week, and event count. Well, what's going to happen behind the scenes? OBI is actually going to generate a query that's at the day and employee level. And if you see the math there, it's going to return thousands of rows back to the OBI server, and then it's going to have to aggregate on top of that. So this could be a potentially performance killer right here. So what do we want to do? Just remove the employee and remove the day from the query. Make sure the grains are in sync. All right? We want to reduce the quantity of data each report shows. Right? We don't want to have to place large data dumps on our report. Remember, OBI is not an ETL tool. It is not designed for extracting 10,000 records or 100,000 records. We want to try and reduce the need to do that. Union queries can be very problematic. Possibly there's a way that we can get rid of them. Take a look and try very hard to see, is there some other technique we can use to get rid of union queries? A 5-part union is 5 times the load on the database that a typical query might be. Finally, let's take a look and see from the very beginning when we're walking through our user interface design, are there some things that we want to steer our customers away from? And free-form date ranges where you enter a from and a to date, they don't allow us to actually pre-configure or pre-compute things and use aggregates because they may not fall on a particular, let's say weekly, they may fall across weeks, and you're always going to have to go down to a day level. So, but if you're able to pre-compute and give them options such as the last week, the last 4 weeks, the last 6 months, now we can actually go ahead and using some OBI techniques, those can hit aggregates and they're going to perform better for us. Okay? So let's revisit the performance project that I was mentioning before. So we did a very short performance project. These are the things that we looked at. We added fact table partitioning. I changed the model from a Snowflake to a Star. We put proper indexes on our fact tables and our dimension tables. We added 2 aggregates. We removed extra fields in the criteria tab on the reports. We even eliminated a couple of union reports that did not need to be unions. And for one particular report that was very, very slow, we had to do a little bit more work. The report was very slow because it didn't have enough fields, enough usable fields, and a lot of additional report logic had to be done. So we had to go ahead and provide that in the RPD for this report, and we rewrote the report. So although we're not quite complete with the effort, even though many reports still have some complex logic in them, we now have the majority of our reports are running under 10 seconds. Our slowest report went from 9 minutes down to 3 seconds. Right? I believe that all of our reports can run under 7 seconds. We just haven't gotten to the rest of them yet. So, you know, these techniques that we've laid out here, they do in fact work. If you follow them as I've laid them out, you're going to get excellent performance with them. One thing I want to mention here at the bottom, this is not a report tuning exercise, a report tuning techniques. This is a overall model tuning exercise. So any new reports that a particular user might make, it's going to be on top of this foundation of performance that we've built. All the things that we've already done are going to benefit any new report. So we're really tuning the model, not tuning, you know, a list of 10 reports and things like that. That's not scalable. The model is scalable. Right? So just to summarize here, remember that OBI is a SQL generation engine. The database does the heavy lifting here. So we need to make sure we give the database some advantages. We use the features it has. We work on a good design. And we have to remember that the SQL is what accesses. It's the handshake to that good model. So we want to make sure our SQL is perfect. So I would say about half of it is going to be in your database, and the other half of the handshake is going to be in your OBI server. And with that, Jeremiah, I think I can turn it over for some questions.
All right, sounds good. First question we have here. Can you explain a bit more about when star transformations or aggregates should be used?
Okay, good question. Star transformations versus aggregates. They're not mutually exclusive, but each one of them is tailored for a particular kind of use case. A star transformation is going to be more applicable for detailed reports. In other words, if you have a lot of filters on your query where you're filtering on many different dimensions, you're not scanning 6 months worth of detailed records. You're only going to scan, let's say, a couple of days worth, where things are constrained. A star transformation will allow you to take a very large fact table and very quickly and efficiently find only the very small subset of records that you're interested in. Right? Now, that's not always the case. Sometimes we do need to scan a large set of records when we need to look at trending over the last 6 months, for example. Well, a star transformation may not be as beneficial for you there because we're dealing with a lot more records. So that's where an aggregate table can help out. We're pre-scanning those records and pre-computing them. So, and furthermore, here's a great thing about star transformations. You can apply a star transformation on your aggregate, right? So even if you're aggregated by month and you have many years inside your database, you can now get to one particular month or a set of months or even fields within that month very quickly. So they're not mutually exclusive, but keep in mind aggregates are better for summary level reports where lots of data has to be examined, and stars are excellent, the best technique for doing more detailed reports.
Okay, next question. How much does it matter where multiple SQL statements are joined together, in the database versus the BI server?
Okay, yeah, I talked a little bit about that one earlier on, and I've seen it in both cases, and I really think you need to benchmark this. One particular example, you know, if you follow the philosophy of Oracle and what folks say about it is to push everything into the database. Well, that means if you have a very complex query that has to fire multiple select statements, well, one query could be one very large monster query with 3 or 4 select statements in it, and they're all full outer joined together. They're stitched together inside the database. Well, I have seen cases where that does not perform very well. The database server actually becomes CPU bound because it has to do all these merges, all these nested loops and things. And I've seen cases where the CPU on the database server is our main bottleneck. Well, with that in mind, you can actually change the way OBI generates the queries, and you can have the Oracle database return a set or a series of smaller queries, hopefully smaller result sets, and let OBI do the joining. When we did that, what we were doing is we were shifting the workload from the database CPU over to the OBI server CPU, which we had a lot of free capacity on. And in doing that, we got a substantial performance bump. Now, that's one particular case, one particular example. As I said before, I really think you should try it both ways and see which is going to happen, which is going to be best for you. And I would strongly recommend you do this, not just by logging into a dashboard page by yourself. I would recommend you do this during a load test. Using Load Runner or whatever tool you have, run hundreds of concurrent users at the same time so you really start to flesh out where your true bottlenecks are.
Sari asks, will a lengthy pivot table cause performance issues?
Well, it's not so much the pivot table, right? It all comes down to the SQL statement behind the pivot table, right? If your pivot table is going to be returning 40,000 records, then yeah, it's going to perform more slowly. Again, the majority of the time exercise here is going to be inside the database. There's going to be a little bit of effort for OBI to actually draw and render the pivot table. But whether you do it in a pivot table or just a straight table, the SQL statement behind it is typically going to be exactly the same. So the OBI layer and the database layer, all that's going to be identical. So I think to answer your question, I would say pivot tables typically do not have a tremendous or a negative performance impact unless you're going to start using some of the features inside of the pivot table, such as building a share calculation and whatnot. Then it may generate more levels and more subqueries to do subtotals and things like that. So apples to apples, the answer is no. But if you use some of the additional features and capabilities of the pivot table, then the answer is probably yes.
Okay, great. Brandon is using OBIEE version 10.1.3.4, and he's got a question regarding the select distinct. So how do I get rid of the select distinct that seems to end up on all of my SQL?
Yeah, that's been a question that we've been dealing with for years. The answer is you can't. That's just the way OBI works. It always puts select distincts in there. Even if you do a select on a primary key, it's still going to do a select distinct. It's just the way OBI works.
Larry asks, can you explain again how the maximum connections in the connect pool affect the OBI tool?
Right. So if you have a page with a bunch of reports on it, and a user comes in and loads that page, OBI may fire off, let's just say, 12 queries to the database. Right? Now, if your connection pool is set to 10, well, 2 of those queries are going to have to sit around and wait until one of the connections is freed up. Right? So that's the situation we don't want to have. So what we would do is we would set our number of connections to be big enough to handle those pages. And then we also need to factor in multiple users at the same time. So we take a look at our user load. How many concurrent users do we expect to have running reports at the same time? Look at the pages that we've actually constructed, and we need to do some math about the number of queries on those pages times the number of users we expect to be running at the same time. So if our example is we have 12 queries on our largest page and we expect 10 users at the same time to be running that, well, we would need 120 connections. So that's what we should try and set it at. Of course, you need to make sure you don't overdo it. Make sure your database can handle that workload. So I would first start with doing the basic math there, load test it, and then maybe once or twice you move that number up and down to see how the database can handle it.
Rajesh asks, can you talk about clustered databases for a moment? Do you recommend a clustered or a non-clustered database for an ETL/Oracle BI environment?
That's probably a little bit more beyond the scope of what I wanted to address here. It was more about planning. Clustering, I've seen some cases where databases are clustered. I've also seen customers who recommend not to use something like Oracle RAC. They'd rather use a single larger box. Typically, I don't see clustered databases as much as you would, let's say, on the BI server layer or an application server layer. On the ETL tools, yes, I do see them there. But for the database, typically, I don't see them as much as you might think.
Dimitri asks, do you have any particular advice on how to handle slowly changing dimensions?
From a modeling perspective or performance perspective? From performance, it is another dimension, right? And it's going to join in the same way that any other dimension table would join. If you rekey it with your surrogate keys, it's going to act just like any other dimension. What I would recommend, and I didn't really cover this, is the indexing on your dimensions. We can put bitmap indexes on the common fields that are actually used, both in the join and in the lookup. So I don't think there's anything special that you need to do for a query performance perspective for slowly changing dimensions.
Jody asks, in one of your previous examples where you were joining or merging, or the joining/merging load was shifted from the Oracle database to the OBI EE server, how was that done? Is it simply done by changing a database feature?
It's set in the, yes, it's done in the database features tab, which is in the physical layer, right? And that controls how you configure your SQL, how the SQL will be generated. And there's a couple of features in there that the perf prefer internal stitch join is the primary one. There's also one called row num supported, which also factors into this. So those two features in combination will actually dictate whether OBI does the join or whether the database does the join.
Sorry about that.
In fact, actually, I've written about that extensively. I do have an article for more details on that on my blog site.
Deepak asks, if we have several pages on a dashboard, will that affect performance in any way?
No, so multiple pages is a good thing because what you're doing is if you have simply a lot of reports and a lot of information to convey, you're breaking it up across multiple pages, and that's a good thing. Because the alternative is you put many reports on one page, and now you have a very heavy page. And heavy pages mean that things are running at the same time. Everything's flooding the database with requests at the same time, and that's going to impact your performance in a bad way. So multiple pages are fine. It's a good practice to do that.
Question from Vikas. For example, if a report fires 10 queries, will all the queries be executed and started at the same time and executed in parallel, or are the queries executed sequentially? Did you follow that?
Yeah, they'll be executed in parallel by the database engine as long as it has the capacity to do that. So 10 queries flooding the database, they're basically going to come over at pretty much the same time, and then the database is going to start working on them one by one. Excuse me, not by, as soon as it comes in, it's going to start processing it, and then it's going to hand the results back as they come along. So the slowest running query there is going to be what determines when the report finishes.
Jeff, you want to tell people where they can find your blog?
Yeah, my blog is at greatobi.wordpress.com, and I actually have more details in a recent article about the performance numbers that I addressed on a recent project. There's also one on there called To Stitch or Not to Stitch, which discusses the pros and cons and how to control where the stitching happens in the OBI server or the database server.
There's one more question on here for me from several people. Will the recording be available from today's event? For an archived recording of this webinar, you can visit the KPI Partners YouTube channel in the coming days. And if you're a follower of KPI Partners on Facebook or on Twitter, you will definitely receive a push notice that the recording is now available. So I think that concludes the Q&A portion of the event. For complete detail and registration for all future webinars and workshops, please visit kpipartners.com. Thank you to everyone for joining us on today's webinar, and thank you to Jeff for presenting. Take care, everyone.
Thanks, everyone.